Okay, part 2, I guess. Well, they had some pretty grand ideas. Alright, we'll go back to here. Okay. The crew in Booster 1 will be in complete control at this time. But if an emergency occurs, the 3 stages can be separated, each to find its way to a safe landing under control. The ship tilts slowly to the east after 90 seconds and all the propellant of Booster 1 is used up. The first separation now occurs with the upper 2 stages being ejected forward. The big clamshell doors of the nose of the Booster 1 close as it prepares to re-enter the atmosphere and glide to the landing. Somewhere in the vicinity of Big Springs, Texas, it will be low enough for the pilot to put down the landing gear and bring a huge booster to the ground at a landing speed of 175 miles an hour, much like an ordinary airplane. You'll catch them with chopsticks too nowadays, eh? The upper 2 stages continue their flight without Booster 1, and after 125 seconds, Booster 2 runs out of fuel and separates, leaving the upper stage on its own. The nose doors of Booster 2 close and it makes a landing somewhere to the north of Prentiss, Mississippi. The final stage keeps on accelerating for another 70 seconds, then coasts upward to its rendezvous with the space station, 1,075 miles above the surface. Oh, that's a lot higher than what ours is, at 120 miles up. When it reaches the satellite orbit, it makes a final maneuver of 4 seconds duration and the trip is complete. But on the ground, there isn't much activity at Big Springs, Texas, and Prentiss, Mississippi, or Missouri, maybe. Jet engine pods are being slung under the delta wing for the 2 boosters to convert them into a large jet airplane. This will probably take only a day or 2 for this simple procedure. Jet engines are removed and new ones installed on the jet bombers today in a matter of hours. Then the crews fly the booster back to White Sands. Take off is made with full power of the jets, 16 of them, 1 booster on Booster 1 and 8 of them on Booster 2, plus about 10% of the rocket's motors. Once in the air, the rocket engines are shut off and are used only for emergencies. The boosters fly on like normal airplanes under the thrust of their turbojet engines. After both boosters have landed back at White Sands on long runways, the engine pods are removed and shipped by rail, truck, or air back to Big Springs or Prentiss. The big boosters are then given a careful and complete check and overhaul. Any needed repairs or modifications are made. Then they are made ready for assembly onto the complete spaceship again. The final stage of the ship makes its return from 198. There we go. The space station is the same manner as any of the craft visualized for space flight. It operates its rocket engines against its orbital speed and begins to spiral slowly back to the ground. At about 20 miles altitude, it enters the atmosphere, and the stubby delta wings enable it to glide down to a landing at White Sands in the same manner as the boosters landed at Big Springs and Prentiss. There it is also checked out and assembled atop the boosters, ready for another flight. What is so different about the idea of manning the lower stages with crews? In the first place, there is a greater margin of safety during the critical takeoff phase. If there is trouble, each booster can be guided to the ground by its own crew instead of being left to fall freely on the land below. And there is a factor of weight. The crew and their associated equipment would actually weigh less than a parachute system designed to lower such a large booster to the ground. Another advantage of the system is that each booster may be tested by itself in the research and development phases of the project at first. They can each be flown as an ordinary airplane with both jets and rocket engines. New crews can be trained this way without subjecting them to a full-scale satellite flight before they had learned their jobs. The system, in addition to other advantages listed above, can make more trips in a given period of time due to the speed with which the boosters can be recovered, brought back to White Sands, and checked out again for flight. So the ship can actually transport a greater amount to the space station in a given length of time. Okay, well, we go where? The system, in addition to other advantages listed above, can make more trips. Okay. So the ship can actually transport a greater amount of space. Okay. Space travel. Space travel is going to cost a lot of money, so a cheap scheme which appears to save money, equipment, and time should not be overlooked. Engineers everywhere have always been interested in building or doing something in the most economical manner. That is why the manned recovery system of Ron McKnight and Van Pelt is so important. It is such a logical system that it may very well be the type of spaceship with which it will establish the station in space. An American Sentinel Beyond the Sky, which is the first step in the conquest of the endless frontier. Time will tell. The only thing remaining to do is wait and see. Not if it will be done, but how. Alright, okay, have a nice day.